So here's a quick refresher on how to use the chain rule. First we want to look at the notation. Recall that if we write y equals f of x, then y prime equals f prime of x represents our derivative function. But what if y is a composite function? Then we need the chain rule to differentiate. So let's start with looking at how the composite function can be written. Y can be f of another function, g of x. Then the derivative with chain rule is the derivative of f with respect to the inner function g, and then multiply by the derivative of g. For example, what if we have this y equals 1 over 3x squared plus x? We need y prime. First we have to find the composed functions. Notice that we have 1 over something. So we can let our outer function f of x be 1 over x. When it's 1 over something, we just make that something be x to simplify the composed function. And in order to take the derivative of it, we'd rather write it in power notation, so we'll write that as x to the negative 1. Then our other function, g of x, is 3x squared plus x. In order to do the chain rule, we need all the derivative parts. Let's find the parts of each, the derivative of each part. The derivative of f is x to the negative 2, negative x to the negative 2. And then the derivative of g is 6x plus 1. So when we look at the composed function f of g of x, our derivative is going to be f prime with respect to g. So g isn't changing. That whole entire g function is going to be instead of x in f prime. And then we multiply it by the derivative of g. So y prime is going to be the derivative of x, the derivative of f with g untouched in the middle, times the derivative of g. So looking at it at the end, if you start with this as your y, then this is the simplified form of your derivative. And you should verify that. Try it on your own and make sure you can recreate that and that it makes sense. But what happens if we have 3 composed functions? Okay, so if we're given that y is this function and we need the derivative y prime, first let's identify the 3 composed functions. Sine is one function, but then we're cubing it, so that's a different function. Sine takes an argument, and that argument is another function. So I'm putting each function in a different color. So our outer function, we'll call f, is that it's something cubed. According to order of operations, that's the outermost function. So the next one is, we'll call g, is sine, and the innermost function, we'll call h, is the square root of x, which we'll write as x to the 1/2 because that's the easier way to take the derivative. So now we can think of this function y as f of g of h. And you see the colors are coordinated so that we can keep track of the parts a little more easily. Now we find the derivative pieces. The derivative of f is 3x squared, the derivative of g is cosine of x, and the derivative of h is 1/2 x to the negative 1/2. Don't forget to subtract 1 from the exponent there. And then the derivative is this beautiful, colorful combination, f prime of g of h of x. It's the function g of the function h, not their derivatives. And then we multiply by the derivative of g. So this is unraveling the chain. Derivative of g with respect to h, and then finally we get the derivative of h. So we'll put that all together and get this, which can be simplified. So if we have our original function, sine cubed, of the square root of x, the derivative in simplified form is this. And you should also verify that. I hope this helped. Thank you for watching.